Hi, everybody. Module 5 is all about the history of astronomy and telescopes. First off, let's talk about the history. History of astronomy is just so interesting because it is the history of science itself. One of the first most important things that scientists looked at was the sky. We used it to tell time. We used it to help determine the seasons and when to plant, when to harvest. It's just part of human history and very important stuff. So last week we began with heliocentric and geocentric models, and we talked through Brahe and Kepler. This week we're going to start talking about two of the most important scientists of all times, and that is Galileo and Newton. So we're going to talk about their contributions to astronomy specifically. Then we're going to talk about telescopes, and one of the most fascinating things in the world is there are two standard telescope designs, Galilean and Newtonian telescopes. And there have been modifications and changes and updates to those, but we're going to talk about their telescopes and then how they have been deployed and made better through the years. The Hubble telescope, the James Webb telescope that's going to be launched very soon here, are definitely modifications of the Newtonian design. The lab this week is all about Kepler's laws. And so it is a historical lab, but though rules that Kepler came up with hundreds of years ago still rule astronomy today. Well, they actually don't rule, they actually explain how the one object orbits another, which is just fascinating. So let's take a look at Canvas and let's take a look at that lab for this week. So we'll start out talking about Galileo and his discoveries as they relate to astronomy. Remember that study guide is your second instructor. Newton and his law of gravity. Gravity, folks, control everything in the cosmos, from the creation of galaxies to the great attractor, which we'll talk about later. Refracting and reflecting telescopes, those basic types, and then important telescopes. Everything from Hubble, James Webb, Subaru, Kitt Peak. They are the superstars in the land of astronomy, and those are those important telescopes. And then newer technology called adaptive optics that have made ground-based telescopes very, very useful. Kepler's Law Lab, we'll go into a discussion of that in a moment. Our constellations this week. And then the quiz this week is going to be over Kepler's Law and telescopes and Galileo and Newton. So that's what's up for this week. Let's talk a little bit about this week's lab. A little bit about the study guide. Again, we are crossing multiple chapters, so please follow the chapter and section numbers. We're going through the chapter on history, and then we're going to go back and talk a little bit about the telescopes. Just a word about the telescope chapter. The authors really wax eloquent about telescopes, and so I am going to try and lead you towards the stuff that I think is more fascinating and interesting to us. Kepler's laws, Kepler's first, second, and third law. The first law is that law of elliptical orbits. And so I'm going to ask you to review his laws a little bit. And then a big part of the lab is I'm going to ask you to draw some ellipses. This is a big part of the lab. The lab is worth 20 points, and 9 points of it is for you to draw and fully label 2 ellipses. So I took a lot of individual images as I was drawing these ellipses. You're going to need a piece of paper, a couple of pins, a piece of cardboard. You know, honestly, a cereal box will work if you don't have cardboard to stick these to. You're going to need some string and a ruler that has some centimeters attached to it. Follow the instructions. I took a lot of pictures as you go along. An ellipse is different from a circle. A circle is everything is equal distant from one point. An ellipse, the sum of the distances are equal from 2 points if you add these two distances together. So you draw an ellipse using 2 push pins and a piece of string. So you're going to draw 2 ellipses, and then you're going to calculate something called the eccentricity. If you haven't watched the notes yet, that's okay. That's why this is the first video on the unit. But it's really easy. You do some measuring and one quick division, and you can do that with a calculator. and I'll show you how to measure those numbers. You are going to calculate or look at and label the aphelion and the perihelion. Aphelion is when a planet is furthest away from the sun, and perihelion when it is closest to the sun in its orbit. So you are going to create 2 pretend planets on your 2 orbits around your sun, calculate the eccentricities of both, and you're going to upload your ellipses. This is the ones that I created: Planet Maudie, named for my cat, and Planet Bob, because when in doubt, I name things Bob. The eccentricities of the planets, I'm going to ask you to calculate the eccentricities of the planets of our solar system. Just a quick division, and that equation is right there. Then we're going to go to the University of Nebraska. We are going to only use 1 simulation for the entire rest of the lab, but this simulation incorporates Kepler's first, second, and third law and Newton's universal law of gravity. So when you get there, I'm going to ask you to go to the upper right-hand corner, and then you're going to switch between individual planets. And as you switch between planets, you can see the eccentricities of each of those, and that gives you a lot of insight. Some planets have small eccentricities, which means they have a very, very round or circular orbit. Some planets have very much larger eccentricities, which means their orbits are much more elliptical in shape, which is pretty cool, and gives us a lot of insight into each one of those planets. One of the other things I'm going to ask you to do is sketch the 2 foci of, we're going to work with 3 planets primarily: Mercury, Earth, and Saturn, mostly because we can't work with all of our 8 planets, and Pluto. I include Pluto because it's kind of fun here in this simulation. And you're going to change this. You're going to look at the foci. So in the first law, the sun is 1 focus, and then there is a mathematical point, which is the empty focus. And I'm going to ask you to start that animation. Whoops, show grid lines. Show grid lines. Stop the animation. Show radial lines. That's what we want to do. And start that animation. And I want you to see that's how that orbit goes. And of course, we can slow that right down if that's going a little bit fast. But it shows how eccentric. So sometimes this planet is a long way from the sun, Mercury, and sometimes it is very close to the sun when it is at perihelion. So that's kind of fun. And you're going to switch between planets there. We're also going to use the Kepler's second law feature in this lab, in the simulation. When you get to the Kepler's second law animation, I'm going to ask you to start the clear options. We are going to sound effects, sweep continuously. We're going to change this to 1/10. 1/10. Show grid. Adjust size. I think we're ready. If I go, nope, I want to do one more thing. Start sweep and go. Second law is all about the planet will sweep out equal areas in equal amounts of time. And I want you to see this. What this means, ladies and gentlemen, is it actually shows you that the velocity of the planet will change. Sometimes it's going to appear to go past very fast, and sometimes as it's further away, it's going to go slower. So please follow the little yellow brick road in the lab as you answer questions here. I'm going to ask you to use the simulation to make a pretend comet. Let's push this to the extremes of the simulation. What happens if you have something that's far away, very elliptical orbit, and what occurs? And last but not least, we're going to use the Newtonian features of the simulation, which is way down here. And with the Newtonian features, we're going to look at some gravitational effects. So lots going on as usual. Please enjoy drawing those ellipses. Every astronomy class in the universe draws ellipses. So this is kind of a big deal And it's kind of fun. If you like things that are real tactile and drawing, which I like, I think you're going to have some fun with it. So have a grand week, and we'll talk soon. Bye-bye.